Micro and nanoplastics destroy intestinal barriers. The intestine is not just a digestive organ. About 70% of the cells in our immune system are concentrated there, which means its condition directly affects the protection of the entire body.
So another study that we provided, showed us we are actually eating plastics, microplastics, because we analyzed 26 human cadaver. We just investigate their intestinal system, their gut content, and we found like between 9 and 10 microplastic per person in their stomach. So this is like a acute exposure. At that time, they exposed that amount of microplastics because when you eat something, it will pass through your intestinal system. Some of them will remain inside the system. This is what we found: the remain microplastic particles inside the human stomach, because grams doesn't give enough information about exposure, because the particles behave according to their shape rather than their mass, because the definitive transportation feature of plastics or particles is size, because all the human barriers, the gut barrier, intestinal blood barrier, they are selective for size and the type. If they smaller than certain size, like 100 micron, they can pass through through intestinal system to the blood system.
The intestinal barrier works like a filter. It allows useful substances, vitamins, nutrients, to pass through and blocks harmful ones, toxins, microbes, and foreign particles. But this entire well-coordinated system is destroyed by electrostatically charged micro and nanoplastics. It damages the cells lining the intestinal walls and weakens the tight junctions between them, making the intestinal barrier more permeable. Microbes, toxins, and plastic particles begin to penetrate the bloodstream from the intestine. In response, the immune system triggers inflammation. The intestine is also the body's second brain. Its walls contain about 500 million neurons that are directly connected to the central nervous system. This connection is called the gut-brain axis. The gut and the brain are connected through the vagus nerve. It is like a direct phone line through which they constantly exchange messages. The brain gives commands to the intestines on what to do, and the intestine informs the brain about their condition. A key role in this communication is played by the microbiota, 100 trillion beneficial bacteria. They produce substances capable of both calming and irritating the nerve endings in the intestinal wall, including those of the vagus nerve. Charged micro and nanoplastics disrupt the balance of gut microbiota. Beneficial microorganisms die, while pathogenic ones begin to multiply actively. When this happens, the communication between the gut and the brain becomes distorted. When nanoplastics enter the intestine, it triggers a vicious cycle of destruction. The damage that begins in the intestine leads to systemic malfunctions throughout the body. The digestive, immune, nervous, and endocrine systems all suffer. This accelerates the body's aging process and increases the risk of serious diseases such as irritable bowel syndrome and inflammatory bowel diseases, allergies and autoimmune diseases, depression, anxiety and cognitive disorders, obesity and diabetes, cardiovascular diseases, neurodegenerative diseases, such as Alzheimer's and Parkinson's. Micro and nanoplastics destroy immunity. Researchers from the University Medical Center Utrecht discovered that immune cells exposed to nanoplastic die 3 times faster than those that are not. Such accelerated death of immune cells severely weakens immunity and reduces the body's ability to fight infections. This contributes to the spread of inflammatory reactions throughout the body. Scientists from Utrecht University and Henan Cancer Hospital in China have found that nanoplastics penetrate even into the bone marrow and the thymus, the organs where blood and immune cells originate and mature. The bone marrow performs two key functions. On the one hand, it is a blood cell factory, where red blood cells, white blood cells, and platelets are formed. On the other, stem cells of the bone marrow play a role in regenerating bones, cartilage, muscles, and fat tissue. The impact of nanoplastics on stem cells means damage to the very foundation of regeneration. First, blood formation worsens. Anemia can develop due to a lack of red blood cells. Immunity decreases due to fewer white blood cells. And the risk of bleeding rises because of platelet deficiency. Second, damage to bone cells makes bones more fragile, increasing the risk of fractures and slowing their recovery. Nanoplastics not only destroy the immune system, but through its electrostatic charge, they also create conditions for the reproduction and resilience of pathogens. A study from the University of Illinois showed that positively charged nanoplastic particles increase physiological stress in gut bacteria such as E. coli, making them more pathogenic. The electrostatic charge plays the decisive role here. It is what increases the pathogenicity of microorganisms. At the same time, nanoplastic particles without electrostatic charge did not cause physiological stress in bacteria, and their danger to humans did not increase. The experiment showed that microplastics, especially polystyrene, can absorb up to 98.6% of viruses, prolonging their survival outside the body for up to 7 days. Viruses that normally die under sunlight or oxygen within hours can persist on plastic for 2 to 7 days, remaining on surfaces such as handrails, bottles, and door handles. A single sneeze from an infected person can release up to 200 million viral particles into the air, which can land on any plastic surface indoors or bind with nanoplastic particles in the air and water. Microplastics become an air and water taxi, spreading infection. Once in the bloodstream, charged micro and nanoplastic particles quickly become coated with plasma proteins, forming a biocorona, which masks them as the body's own cells and makes them invisible to the immune system. Antibiotic resistance. In 2019, antimicrobial resistance was directly responsible for more than 1 million deaths, with nearly 5 million additional deaths linked to related complications. Studies in 2025 show that plastic helps bacteria develop resistance to antibiotics, driving a crisis that medicine is increasingly unable to control. Why? Because plastic is the perfect platform for bacterial growth. On its surface, they easily form biofilms, a dense protective layer shielding bacteria from sunlight, drying out, immune system attacks, and, most importantly, from antibiotics. Just like viruses, bacteria can survive on plastic longer than on other materials, sometimes for 3 days or more. This makes microplastic an efficient carrier of dangerous microbes through water, soil, and food. Paul Dabzak, PhD in water chemistry and microbiology, researcher at Center for Research in Exact Sciences and Engineering at the Bolivian Catholic University San Pablo, notes that the presence of biofilms on microplastics makes them even more dangerous.
In the laboratory, we study how microplastics interact with metals and microorganisms. We observe that microplastics can adsorb metals through both physical and chemical sorption processes, and that this ability increases in the presence of bacterial biofilms that develop on the surface of the particles. These interactions depend on the type of plastic and the size of the particles, which alters their electrostatic charges. This causes microplastics to act like a magnet, attracting even more contaminants to their surfaces.
In laboratory conditions, researchers from Boston University found that when bacteria come into contact with microplastic, they activate a special metabolic process linked to electron transfer. Simply put, Plastic particles can share electrons with bacteria, acting as a kind of power bank for them. This process is called extracellular electron transfer. It gives bacteria extra energy, which first of all, makes them stronger, helps them divide faster, mutate, and build resilient multi-layered biofilms that block antibiotics from penetrating. Secondly, this extra energy directly accelerates antibiotic resistance. What's worse, even after plastic was removed from the experiment, bacteria retained their new properties. They mutated, became more resistant, and continued forming strong biofilms on other surfaces, even without plastic support. This means plastics may accelerate the rise and spread of the so-called superbacteria that are resistant to drug treatment. According to WHO estimates, by 2050, antimicrobial resistance will claim 10 million lives every year. Meanwhile, new antibiotics are being developed far more slowly than bacteria evolve.
So think about this. Charged microplastics not only help bacteria to survive, but they also enable them to mutate into superbacteria that are resistant to antibiotics. This discovery reshapes our perspective on plastic pollution because we now understand that the problem is far more alarming than we have previously believed. And each year, the threat of antibiotic resistance is growing. In many countries, standard drugs are already losing their effectiveness, and even common infections are becoming increasingly difficult to treat. If this trend continues, antibiotics could soon become entirely useless.
Micro and nanoplastics affect the respiratory system. The inhalation pathway of micro and nanoplastics is especially dangerous because plastic particles carrying an electrostatic charge can reach not only the lungs, but also travel directly into the brain through the olfactory pathway. Chinese researchers have estimated that in just 2 hours outdoors, an adult can inhale up to 106,000 microplastic particles, and a child about 73,000. Given the lower body mass of children, the concentration of inhaled microplastics per kilogram is on average 4 times higher in children than in adults. Once inside the respiratory tract, micro and nanoplastic particles carrying an electrostatic charge trigger a chain of destructive reactions in every cell of the bronchi and lungs. They cause oxidative stress and chronic inflammation, leading to severe consequences such as the onset and worsening of bronchial asthma, progression of chronic obstructive pulmonary disease, pulmonary fibrosis, in which healthy lung tissue is replaced by scar tissue, and an increased risk of malignant tumors of the respiratory tract. In a study conducted in 2021, microplastics were found in 13 out of 20 lung tissue samples. In patients with respiratory diseases, particles were found in every sample of throat phlegm. What's more, plastic fibers have been discovered in malignant lung tumors. According to the World Health Organization, lower respiratory tract infections remain the world's deadliest infectious disease and rank among the top 5 leading causes of death. Cancer of the trachea, bronchi, and lungs ranks 6th among the leading causes of death. Micro and nanoplastics disrupt the functioning of the heart and blood vessels. Cardiovascular diseases are the leading cause of death worldwide. Despite tremendous efforts by the scientific community to develop and introduce innovative treatments, both the incidence and mortality from these diseases continue to rise.